Very good.
Okay, good afternoon, and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm Richard Restuccia, Vice President of Water Management Solutions for Jane, and today we're going to be talking about one of my favorite subjects, and it's valve troubleshooting. And one of the reasons why it's one of my favorite subjects is because I think all of us from time to time, every year, come into a situation where we have a problem with a valve. And so oftentimes your ability to troubleshoot this speeds the process to a fix. And let's face it, without the valves working properly, your plants, your landscape is just not going to get the right amount of water, and it's ultimately going to hurt you and your situation. So learning how to step through and troubleshoot valves from somebody with as much experience as Michael Pippen does is going to be really helpful, right? Because again, I think we all probably have our own strategies, our own step-by-step, and it's really generous of Michael to share his with us today. You know, for those of you who've seen Michael do some of these presentations, you know what a great presenter he is. The thing that I think is great about Michael is he's really spent his entire life in agriculture. This is somebody who can speak to us, teach us through a practical sense. He's worked in ag, he's worked with dealer, and he's worked on the manufacturer side. So he's seen all aspects of irrigation and can really relate to the challenges you all have when you're in the field having problems. And in this case, with your valves, you know, we were talking earlier and I said, man, there's a lot of different ways to get experience. And Michael shared with me how he gets his experience. And we're going to share that with all of you here in just a moment. So anyway, Michael, welcome back. So excited to see you today.
I appreciate the opportunity, as always, Richard, to hopefully share a little bit of knowledge that we've gained over the last however many years, and hopefully have a good time as well, sharing that. And we hope we have the opportunity to answer questions during the presentation or after. If you have anything specific, please drop that in the chat line for Richard. And he'll get those to me, and we'll get them answered either during the presentation or afterwards. So yeah, thanks again for having me, and look forward to talking about this topic today.
Yeah, so Michael, I know you were involved with the certification board at the IA for 9 years. You served as the chair. You've got this experience in the field and as a dealer and manufacturer for many years. I mean, you've really seen all aspects, but what would you say is the best way that you've built your experience? How did you learn about valve troubleshooting? How did this come about?
Well, I would say that I do have kind of an educational background that probably laid some foundation for me, although I probably didn't know that at the time, right? I'd not really studied irrigation valves in college, although I did study a lot of hydraulics, kind of laying that groundwork. But really, when I came, in college and out of college, I spent a lot of time at a dealer, distributor, and we sold a lot of valves in landscape applications and in ag applications. And so through that was really where I learned, really the intricacies of how the valve works, specific irrigation valves, and how to troubleshoot them the best of my ability. And then sometimes knowing where to go get help and when to raise the white flag and go find somebody that knows more about it than you do. So I think it's a mixture of having an educational background and then being out in the field with a valve that won't do what it's supposed to do on a hot summer day, right? That's really where the rubber hits the road, and where you learn how to troubleshoot and what works best for you, and the best strategy to get to the solution as quick as possible.
Yeah, so I imagine you've seen your share of troubleshooting calls that have come through. I'm in the field, help me, drop whatever you're doing and help me now because I got a problem.
Yeah, and I would say that's kind of where we started talking about this presentation today, putting it together. I did a lot of troubleshooting over the phone, which is much different than doing troubleshooting out in the field where you can tangibly put your hands on things. Now, when I was doing that troubleshooting on the phone, it was not uncommon for us to run back to the warehouse and grab at least something similar to what they were messing with out in the field and try to, so you can physically put your hands on there. But it really is a more challenging type of troubleshooting because you really have to rely on the information receiving from the field. And so that individual may or may not have as good a working knowledge as you do. And so today I am going to spend a little bit of time sharing what I believe are basic troubleshooting skills that can be applied to anything, not just valves, but kind of how we would tackle that when we were in the, not the physical person in the field looking at this thing. We're trying to translate what was being told to us to give the person some solutions. So I'm gonna spend a little bit of time with that. And then I'm going to talk briefly about the operation of a valve and what I describe as the two types of components that are in the valve. We're not going to go into all the valve hydraulics, but kind of give you an idea of what I think is the first step of trying to figure out how to troubleshoot. And then we're going to talk about really the two things that happen when valves are not working properly. And that's kind of how we're going to progress through this presentation, if I can make the presentation progress.
Yeah, and I just had a question about that first slide you had up there. That's a valve we don't normally see in landscape, right? We're used to seeing 3/4, 1 inch valves, maybe a little bit bigger, but this is a big valve.
That's why I put it up there, because it's basically the gnarliest valve that you can find. It was not quite the baddest valve you can find. This one doesn't have any kind of remote control features on there that you can't see anyway. But yeah, this is about as gnarly as they get as far as all the functionality. And that's really the point, is that there can be a lot of things tied onto this valve, but don't let it fool you. They all work the same way as far as troubleshooting. There are different operations and there are different things that you can make them do. But yeah, they don't let them intimidate you with size. They are just a valve, and they all kind of operate the same way.
Yeah, that's a good point, right? Don't let it intimidate you. But yeah, when you see something big like that, I start to worry.
That's right. It looks expensive. We would always say when you're troubleshooting something and they went to go grab the hammer or the big wrench, you go, if it looks expensive, it probably is. Don't hit it with stuff, right? That doesn't help. And that's kind of I should have probably put that as number 5 here, is don't hit it with something heavy. That doesn't usually help. But when I go troubleshooting, especially when we're talking about, people calling the phone where we're not necessarily in the field, you're probably at where the problem is. In this case, it's a valve that's not working properly. I always would ask people to go somewhere where something is working correctly. So in this application, it could be another valve that is working correctly, or maybe it's the controller, or maybe it's a pump. Find some parameters to narrow in the problem. Where the issue is, right? You don't necessarily know where the problem is arising. So, you've got kind of this outside boundary of where bad is, if you will. Go find some good, and look around and see if we can start kind of narrowing that focus immediately, right? If there's a valve next to it that's working fine, that's a big clue. If none of the valves are working fine and the controller is the first thing that you find is good, that's also a big clue. So where the problem is, or at least where the issue is showing up in the field, go find something that is working and give yourself some parameters to work in. And then I say, work towards the problem, kind of splitting the difference. And that can be figuratively or physically. If you're doing some wire troubleshooting, then you would. If your valve is not working and it's 100 yards away, and your controller is working, you'd go to the midway point and see what's working there. And if it is working, then you work towards the problem. If it's not working, you work towards the part that is, right? And kind of split those differences. So splitting the difference I can mean that figuratively, in terms of finding something that's working on the valve and finding something that's not working on the valve and kind of working towards the middle. Or it could be actual physically moving your body halfway between the problem and what is working. And then having the best understanding of how the product works. You do not have to be a specialist to troubleshoot effectively. There's always a specialist somewhere to handle the most challenging issues. I am not what I would describe as a valve specialist. I know a lot about valves. I've messed with them a bunch, but there are valves out there that I haven't messed with a whole lot. There's brands that I haven't messed with. There's settings that I haven't done a whole lot of adjustments on. So if you were to get kind of into more intricate problems or more detailed issues, don't feel like you have to be an absolute, specialist in a product, but you do need to kind of understand how it works, at least in a basic form. What causes this? And so that's what we're going to spend a little bit of time on today. And I would finally say, use your field experience to guide your troubleshooting process. Do not let it tell you the conclusion. it is very easy, especially as you gain some experience, to go out, look at something, and in 5 seconds say, oh, this is the problem, and start going and working on it. You may be right, and that's great when you are, but when you're nothing worse than spending an hour digging up a valve to decide that it's a controller issue, right? So those shortcuts can sometimes backfire. It is always better to kind of work through the process, finding something that is not working, finding something that is, and start working towards that solution rather than going, oh, this is what's wrong, let's go there. It's great. That can save you a lot of time. That's very valuable information, so you can make the highest probabilities of what is right and wrong or what could be happening, but don't let it jump straight to your conclusion. That's a good way to get yourself in trouble.
Yeah, that's a really good point. And I love your other point about go to find stuff that works, right? Because like you said, it's so much easier to start to pinpoint or at least generalize down the area which you're having a problem.
That's right. Now, if nothing is working in the system, that can be really challenging. But we're going to make the assumption today that at least something in the system is working properly. And we're also going to make the assumption that what we're troubleshooting has a history of working properly, not a new installation that's nothing working. So that's probably a good thing. Some of these troubleshooting ideas we're making the assumption that this product has been working properly in the past. So pretty quickly, I'm going to run through what I describe as two components of a valve. This is my terminology, but I basically lump them into two things: a mechanical component and an electrical component. And all valves are constructed very similarly. This is a cross section of kind of like that big blue valve you saw on the opening slide. All irrigation valves have a body, which is kind of this lower portion of the valve where the water flows through. It has a diaphragm that separates the body from this control chamber. The control chamber is just basically an open area that can be filled with air or water. And then it has a bonnet. The bonnet serves as the top of the control chamber and also kind of holds everything together. So body, diaphragm, control chamber, and bonnet. Not a whole lot going on there, right? Pretty straightforward. So when I say the mechanical component, is really talking about the hydraulics of the valve, the water moving through the valve and what is causing that or not causing it to operate correctly. And then I would say, again, for most irrigation valves, we are remotely operating these valves with an electrical command. Now, I use that word command because in ag, we use some different voltages than we do in landscape, but it's the same principle. We're sending an electrical command. We're sending power to a solenoid that actually helps direct the water flow into this valve. So you have two components. You have kind of this hydraulic thing working here, or in this case, working through this landscape valve, or same concept here. And we also have this kind of electrical component hanging on the side that's actually doing some of the controlling. So how do all these valves work? And you can find a bunch of YouTube videos with animations. I didn't go down that road here today because there's all kinds and all different types of valves, and it gets a little bit overwhelming, but you can see some good videos online that will represent some of these types of valves if you want to do that work later. But if you take this cross section of a landscape valve, there's water coming in from the pressure side. This pressure side puts water on the bottom of the diaphragm and water on the top of the diaphragm as well. The water comes over to this point and stops if the electrical signal has not been sent. So in this case, water pressure in, it's on the bottom of the diaphragm, water pressure on top of the diaphragm. The diaphragm has a larger surface area on top, and the inlet pressure forces the diaphragm down, closing the valve. So how does it open? Well, we send one of those electrical commands to this solenoid. And when I do that, it pulls up a little plunger, and now water can get off the top of that control chamber. It's not trapped in there. When it comes off the top of that control chamber, the pressure's equalized, there's some springs in there, and that diaphragm pops up, the valve is open. So you maybe can kind of think about those two types of system. You got a hydraulic system or a mechanical system where you've got the pressure of the water is what actually holds that diaphragm closed. We send power to a little solenoid. Now we let this water escape out of the control chamber. The pressure's equalized, it opens up. So that's kind of the basic functionality of all valves, regardless of what they're doing. Hydraulic valves irrigation valves, regardless if they're pressure regulating or any of those other type of more confusing things, they all operate in the same manner.
So, Michael, I have a couple of quick questions here, and I do want to remind everybody that we've got the chat and the Q&A open. So if you have some questions you'd like me to ask Michael, please send them in there, and I'll ask when it's appropriate. But first question I have is on these solenoids, right? You talked about the electrical impulse going there. Can you manually bleed a valve or open a valve by just doing something to that solenoid?
You definitely can. There's a lot of different ways to do that. Some valves will actually just have a manual override right here. So you can kind of see now that you know that where that bonnet lies and where that diaphragm lies. Right here, this is a valve, and you can open that up, and it would just open water to the air, and it just dumps this water out on the ground. Makes a mess, but it's a great way to open up the valve and kind of get it going, right? You can open that valve, and you can do it this way. And some of the troubleshooting we'll describe a little bit more, but you also can manually lift this solenoid. And by manually lifting that solenoid, it will allow water to pass through the control chamber and open the valve. So there's kind of two ways to do it. Some valves, specifically ag valves, a lot of them have a manual open on top to just bleed water out on the ground. There's not really a great application for doing that in a lot of landscape because they're in the ground and you don't want to open up and fill the valve box full of water. So a lot of times to open them manually, you do have to manually twist the solenoid to make it open.
Which I hate because early in my career, many years ago, I did that once and, it broke. And then I had a whole different problem, right? What I was out there to do that day and what I actually was doing was two different things. So this is why on that Jane valve at the bottom there, that red lever, that can also be used, right, to manually start the valve.
That's correct. It's by definition a test port. It's not meant to control this valve on a day-to-day basis, but it is made to do exactly what we're describing. When you want to manually flip that thing up, manually open that valve, it basically just has a cam on the other side of this lever that you flip it up and it lifts that pilot. So it's the same, lifts that plunger inside the solenoid. So there's a variety of designs, the way they do it. This is nice because like you said, it eliminates the risk of losing a little O-ring that goes between the solenoid and that base that you will never, ever, ever find in 4-inch tall grass. You might as well give up.
Yeah, good point. That's the other thing, right? I've turned it so far it came off.
It happens. And then springs and plungers and O-rings go flying. So it's not always a great way to do it. But it is a great transition over to kind of our first problem. Valves are nice from a troubleshooting standpoint. If you're just considering a control valve like we are today, there's basically two problems. It won't open or it won't close. There's not a whole lot else that can go on with it. Now, we have some other types of valves they're doing different types of controlling. There's some things that can happen there. But, what we're talking today, where we're talking about just a valve that's going to open all the way or close all the way, your two problems are it's closed and it won't open, or it's open and it won't close. So how do I tackle those? And I'll always start with a valve trying to decide whether it's this mechanical issue that I described or this electrical issue. And again, it's that thought of splitting the difference, finding something that's working, finding something that's not, and eliminating half of it with your first decision. So if I've got a valve that's closed and it won't open, the first thing I do is just like you described, is try to manually open that valve. If you have a big ag valve, you can turn it to the open position to see if it'll open up. If it does, that gives you a really big hint that it's probably not that mechanical issue, it's probably electrical issue. Same thing with your NDJ valve that you described here, this Mandan Jane valve. If you flip this little lever up and the valve opens, that's a really big hint that inside, if you want to think about it as the insides, the hydraulic, the mechanical part of this valve is functioning properly. It's probably not that. Same thing here. If you unscrew that solenoid, it opens up. That probably means it's not going to be a mechanical hydraulic issue. It's probably going to be electrical. So that's where I would start. Doesn't mean it can't be hydraulic. It means that most likely it's electrical. And so I start with the electrical side of my diagnosis. And I always start with power. Now, I'm a little old school. There's a lot of controllers that have a lot of features that can really help you out, especially some of the 2-wire stuff is really cool. A lot of that troubleshooting can be done at the controller now, but there really, in my opinion, is still no substitute for a good multimeter that gives you resistance and AC voltage and DC voltage. It does not have to be a $400 multimeter. It can be a $25 one that gives you those three things. You can do basically anything you want to do. So the easiest thing to do, and in my field experience, if you've got good mechanical control by manually opening and closing that valve, the first thing you look for is the connections at that solenoid. You're not getting good electrical power to that solenoid. So a real easy way to do it is to clip off that connection, got good fresh connections, and test the power. See if you've got power coming from the controller. If you've got good power coming from the controller, then most likely you either have a bad connection or a bad solenoid. So now you've really got to a pretty narrow possibility pretty quick. We eliminated the mechanical side, or at least greatly reduced the chances of it being a mechanical issue. We got to electrical with two quick snips of your wire snippers, right? Your strippers and your multimeter. Now you can test, okay, do I think it's near the valve or somewhere between the valve and the controller, right? So you can eliminate some things really quickly. We want to eliminate that solenoid being the problem. If we have good power, then we want to retie that solenoid, hit it again, see if we can get it to fire. If the solenoid doesn't actuate, grab one out of the truck. Before you unscrew it, test that one, see if it'll snap, right, with the cap on there to keep the plunger from flying off, right? If people have done some of this, they've lost a plunger or two in their life. Test the new one before you install it. If the old one doesn't work, new one works, you probably found your problem, right? Pretty quick. You haven't touched a piece of pipe. You haven't cut and glued anything. Life is good. You're winning, right? If the solenoid is working and you're not getting good power, well, then you're going to be a wiring or controlling issue, right? You're going to be you still have to find that good. You've only found, the bad. You haven't found anything to give you the good side yet. You're still not getting any good. It's just all bad to this point. We're not going to go into wire and controlling troubleshooting today, but I would just say if you've got not getting good power at the valve, the very first thing is to go to the controller. Go to the root. Don't go back and try to just go all the way to the root cause, see what you're getting at the controller. If it's good, then you're probably got a long day of wire tracing ahead of you. If you've got a good solenoid and a good controller, but you're not getting the connection, it's probably going to be a long day. That's when you start looking for, paint marks across your yard where the new fiber optics line was run or something like that. You're going to start looking around the system and seeing if you can find a clue. But if your controller, oftentimes, you have a module or something simple, go out in the controller, replace that, and your wiring is intact. So that's how you would check the electrical components. If you decide, go ahead, Richard.
Yeah, a couple points here. One, I want to say thank you for the plug for ET Water controllers powered by Jane Unity, right? They will give you an alert if you have an open circuit or a short circuit, and it'll alert you directly to your email or through a text if you like. So that's one of those controllers that does that for you and makes your life a lot easier by identifying that and alerting you appropriately. And then that was my comment. Then my question is this, Michael. I heard once that most electrical issues, if they are a wire issue, are probably occurring within a couple feet of the valve. Is that true?
Yeah, and I think the root of that comment is that's where your connections are most likely at. That's going to be your hardest place to make connection. Anytime you make a connection or a splice, and especially like where we live in Florida or the Southeast, a lot of rain, a lot of corrosion. I mean, it's always going to be your highest probability of having a poor connection is near your valve, because that's usually where you're making the most connections. The types of tools that are available now are light years ahead of where, you probably have experience like me, the original 2-wire stuff, trying to find a splice that would work and stay, was just really, really tough. We really struggled with that for a long time, but now there's a lot of really good products out in the market that make that less of a problem. But yes, it's near the valve because that's where your splicing are at. So that's where you want to be looking on a wiring problem, or where there's a fresh set of dirt tracks from a trencher. That's also a good place to go look.
Right, over by the backhoe. So
that's exactly right, where the shovel's stuck in the ground. Good place to look.
Yeah. And then one of our viewers is asking this, and I actually have been guilty of this, a situation where you shut the water off to a zone, or you shut the water off to a whole area, and you don't change your controller timing, or you don't shut that off. So your solenoid is getting power every day or every time the water should come on, but no water's flowing. Is that a bad thing? Is that worse than normal wear and tear?
So if I understand the question, you have the water shut off to a valve, but you're still sending it power. So there's no water, but you're sending power to the solenoid. Is that correct?
Yeah, yeah.
It really shouldn't. I mean, the solenoid, I'm trying to think off the top of my head. There are some solenoids that water transfers through them more than others. But in reality, no, they're basically a separate system. Besides just putting hours on your solenoid, they do get weak over time. And especially if you get in an ag valve situation, some of those solenoids are pretty beefy. They're not, and they take a lot of power in terms of solenoids to pull a draw. And so there could be some long-term runtime effects to that. But as far as it burning up and destroying the valve, no, because there's no real mechanical things moving there, right? That solenoid just has a power. It's a magnet. We're energizing a coil and it snaps that plunger up. So it really doesn't matter. I mean, it could have not have a plunger in there for all it cares. It's just energizing that coil is all you're doing. So there's nothing really moving there, except that there is a limited lifespan to all electrical components, but it's pretty minor consideration.
Yeah. Okay, great. Thank you.
Sure. So again, in this valve not open situation, I would suggest that most of them fall on this side, on the electrical side. But it is possible that there's trash in that solenoid assembly. Remember that water can't get out of this control chamber, then it's not going to open, no matter how much power or pressure you put to it. And so so all your electrical is ready. You've checked everything, everything's good. Solenoid's snapping, controller's doing all that's good. Then really your next step is undoing these 4 or 5 bolts across the top and looking in on that bonnet very carefully with the pressure off so it doesn't blow the top off and get all your springs and all your components. But a lot of manufacturers do offer replacement kits. And I would suggest probably at that point, rather than try to clean and if you feel like, this is the problem, that getting a rebuild kit for the diaphragm, and really most likely it's not necessarily a problem with the diaphragm, it's probably some trash or something, but sometimes that's really hard to see, really hard to get out. And a lot of people would just replace the diaphragm at that point. It's a pretty inexpensive fix. But you could get in here, that would be the other issue, right? Water's not coming out of the control chamber. It could simply be clogged up with sand or whatever. I would say, again, we're making the assumption this system has been running for a while and running correctly. If you had a system that was pretty new and ran for like a day and then this valve wasn't opening, I would say PVC shaving, right? I mean, that's the first thing I'm thinking is there's some PVC parts that's either stuck in here on top. These small valves have a pretty small chamber, right? So even like just a piece of plastic, and who knows how they get in there, right? It doesn't make sense, but they will. Some valves have filters on them, some don't. Just know that on a new install, that's a better chance it's something that's got in there than an installation than one that's been operating for quite some time.
Yeah, so we have another question coming in, Michael, and it's from a contractor who's watching today. And he says, I'm a contractor who likes to value engineer my projects. And so I don't use waterproof connectors. I just use regular electrical connectors for my valves. Is that going to cause me a problem?
I think most manufacturers now would recommend a silicone filled wire nut to make those connections. Look, for forever, people would use, little bitty telephone wire, right? Because that's the only thing you can get. And you've probably seen that, Richard. That's the only thing you get, like with 10 strands in it, right? Until, some of our manufacturers in our industry said, wait, let's make a product for irrigation. They did. And so I would say at this point that there's probably products out there that would fill that void where you used to not have that many options. I mean, I'd say there's still a lot of valves out there with just regular old wire nuts or just twisted and electrical tape on there. The reality of it is if you keep moisture out of it, it doesn't matter what you do. The silicone filled wire nuts make that a lot higher probability that you're going to keep that moisture out of there. That's where the corrosion happens. Most manufacturers have even now backed away from the soldering, or I'm trying to think, there used to be with some of the 2-wire, there was like a welding pack that you had to do that wasn't a solder, it was like a chemical reaction thing. It was crazy that you had to do. And and that's just because those are difficult to do in the field, right? If you were in a lab and did them perfectly, it'd be no problem, but it's much easier and much more reliable to use those tools like the gel filled wire nuts than it is to solder down a hole, right? That's just really hard to do. But if you keep the moisture out, however that works for you, that's going to be a successful connection.
Yeah, great advice. Thank you.
So the other problem that we have is that the valve won't close, right? Valve won't open, we want it open. Now we got a valve that's open and we want it closed. I'll take this little, again, we're going to make some assumptions here to narrow down our discussion today. Most irrigation valves are normally closed, meaning that we have to send that command to them, whether we're doing it manually with a flipping the little lever or electronically, we have to send it a command to open up. If we don't do anything to it, it's going to stay closed because that pressure from the pump or from the municipal supply is going to force that diaphragm down. So we got to tell it to do something for it to open up. So most valves are normally closed. That's a big hint to say, well, if a valve is open and it won't close, it's probably mechanical or a controller issue. It's probably not electrical. I say controller issue, and what I mean by that is programming issue. Kind of alluding back to some other conversation we've had before. You know, you get somebody in there that's testing or playing, you know, maybe you have a valve somewhere else that's not working right. You get a time programmed on top of a controller, on top of another program, and all of a sudden you have 12 hours of runtime, and you thought you had 2 hours. And then it stacks and stacks and stacks, and after 3 days, you're basically running every valve all the time, right? I mean, you might have seen that scenario where things just get out of control. And so a lot of the controller, and sometimes, you know, you get power surges and some weird things like that where the controller just putting power to the wrong terminal, and it happens. So that's what I mean by controller issues, is that there's something that's getting bad information from the controller. But that's how I say, okay, well, mechanical or electrical, how do you test that? Well, the other way, when we talked about a valve not wanting to open, we started with a mechanical test. Well, in my opinion, when you've got a valve that won't close, start trying to eliminate the easy things. See if the electrical part is working, right? Just let's take that out of the equation. Again, clip, cut your connections, test the voltage, make sure you're getting the right voltage at the right time. I mean, that may be your hint, right? You go, why is there power here? Like, there's not supposed to be power here. The controller's off, right? Great hint, problem solved. It's a real easy way to eliminate the controller and the electrical part pretty quickly. Even though you got to retie those connections, it's a pretty easy way to do it. So if the power's good, it's coming on at the right time, and it's the right voltage that you're expecting, most likely it's going to be a mechanical problem. If you got bad power, then you're kind of back on this electrical troubleshooting, right? Is it a controller? Is it a wire? Did somebody splice something wrong? Did something get, you know, jumped across, right? You got a lot of issues there. But if you got good power, then it's most likely going to be a mechanical issue. Excuse me.
So, Michael, we've got
go ahead.
We got another question coming in from one of our viewers, and it's a good one, right? He wants to know why his solenoid is so hot when he touches it, right? He's having a problem. He's guessing the fact that this thing's so hot, he can't really even touch it.
I would suggest, so there's always heat dissipated in an electrical component. That energy has to come out somewhere. And so there's going to dissipate heat. Let's just stop the dynamics conversation there. It's going to dissipate, that energy is going to have to dissipate somehow, and it's going to come out in heat. If it's excessively hot, and that's a very, interpret that term however you want to, then I would suspect that it's drawing too much current, meaning it's pulling too hard to get its voltage, which would most likely indicate a poor connection or undersized wire. You will see that in ag applications, I won't say often, but a lot with big old valves that I describe with the big solenoids and those type of things, where the wire side, there's a really high amp draw. So I would suggest if the solenoid is hot to the touch, that's too hot. It's kind of like an electrical motor. You should be able to put your hand on the back. You won't be able to hold it there, but you can hold it there for a second or two and not scald you. Don't do this because you'll hurt yourself. Put your hand on the back, and that'll be the same thing with a solenoid. If you can touch it and hold your hand there for a period of time, without it being slightly uncomfortable and not hurting you, then that's probably okay. If it's hurting you, it's probably doing too much heat, probably pulling power too hard, too much amp draw, which could be low voltage, right? So that could be through a connection. It could be through small of a wire. It could be from a bad output from your controller, but that would be probably the least likely of the three.
Yeah, that's glad you had that distinguishing factor, and this viewer described it as burning hot. So I think we would put that in the classification of too hot.
That's right. I mean, those are relative terms, but if again, you go over to one solenoid, not hot, define it as not hot, and you go over to the other solenoid and define it as hot. Same new electrical motor. This one I can't touch. This one I can. Something's going on over here. So that's reasonable to do with a solenoid as well. So if you look at, what could be causing this from a mechanical standpoint, if a valve won't close, it's oftentimes trash or a tear in the something wrong. Let's not define that as a tear in the diaphragm. Let's just call it something wrong in the diaphragm, right? It can be a tear. They get old and brittle. Some have springs that kind of help keep them closed. Those springs can break. Some don't. So let's call it a diaphragm issue or some trash. Especially in these ag valves, we can get all kinds of junk clogged up in here coming out of an open water source. You can do the same thing with a landscape valve. Again, PVC shaving or something like that, a rock. All these things happen. I have seen a turtle in a hydraulic valve before. Somehow he made it through the pump impeller. So most likely a valve will not close. It's most likely going to be mechanical. Go ahead and eliminate that electrical with a couple snips and a multimeter. It takes 5 minutes to test that and reconnect it if it's not. Then start looking at the mechanical things. I would also say at this point, before I take that valve apart, I do a big, nice, slow walk around the system if I can. Because especially in ag valves, if something else is going on in the system, it can make that valve do funny things, especially when they won't close. For an example, if you had a valve that would not close and right downstream or right upstream from it, you had a big leak that you hadn't noticed. Who knows why? It can be channeling out the trench out the other end. And that system wasn't maintaining the proper pressure. That valve may not close properly because the system can't maintain the proper pressure. You'll see this in ag big valves more than in landscape valves. But the problem is not the valve. The problem is you got a leak on the next zone over, but you haven't looked there because the valve won't close, right? And that can be that's when I say you trust the process. Same thing can happen in an irrigation valve. A valve won't close right. Well, why not? Because there's 7 other valves in the thing open, right? Everything's open. Like the whole system's open. It's in the backyard. You didn't know that, but you do it before you start breaking that valve open. Really take some time, take a breath. You're probably hot. You're probably tired. Take a step back, get your bottle of water, make a good walk around that system, trying to find anything else that could be affecting that valve before you get the shovel. The shovel is when the work really happens, right? So we don't want to bust that valve open if we don't have to. There are situations, usually when a valve won't close, that another component in the system is causing this problem, and it's not necessarily an issue with the valve. It's happened to me before. Valve won't close, leak in the line on the next riser over I didn't see. So it happens.
So, Michael, I think I see a lot of issues with valves that are mechanical, and I see contractors just replacing the entire valve. They're charging about $350 a pop to change out a valve. And I'm thinking, well, there's got to be maybe a valve irrigation kit or something to change out the guts instead of the whole valve, because mostly the outside of the valve's okay, isn't it?
Yeah, I mean, I don't argue with the fact that it's $350 is a reasonable charge to repair a valve, but I do understand that there's probably a very few applications with a valve manufactured, let's say in the last 10 years, that you need to replace the whole thing. They just don't go bad like that. Now, some of the old, if you got a valve that's 30 years old, sure, it could be cracked, it could be broken, it could be no parts for it. That can definitely happen, right? But in the landscape application, most all manufacturers are offering a very high quality, very well made valve. It's been built in the last, I'm just throwing an arbitrary number, let's say the last 10 years, right? That's probably a good valve. It's probably something that you can repair. Most of them offer a repair kit that almost all, I don't know anybody that doesn't offer replacement solenoids. They don't always offer every individual component, right? You probably can't get a plunger of a solenoid, but you can get a solenoid. Might not be able to get the spring off the diaphragm, but you can get a diaphragm kit. And these are relatively inexpensive, and it will keep you from having to cut that valve out. And the body of that valve will be low on the priority list of being a problem. It can be a problem, but especially in a landscape application, probably not. Probably not the problem at all. If it was a body, occasionally, as I said that out loud, occasionally you can have one of these big ag valves that deteriorate right here and that diaphragm won't close all the way. But in one of these landscape valves, that's most likely not going to be the issue.
Yeah, I like my power driver more than I like my hacksaw.
Yeah, shovel saw's bad in general when you're doing irrigation. The work's about to happen if you've got your shovel and your saw out. That's not good. But yeah, Richard, that's about all that I had to share today. I do appreciate the questions and the comments. My contact information is there below, so you can reach out to me directly. If I don't know the answer, I can definitely put you in touch with some valve specialist that I know in this industry. Reach out to Richard, or if we have any more time today, I'll be glad to try to answer anything else briefly.
Yeah, no, this was great today, Michael. I certainly learned a lot about valve troubleshooting. I definitely am going to refine my process and the steps I take as a result of what you taught us today. So thanks very much for that. Thank you to all of you that tuned in today. We really appreciate that. And remember, all our trainings are on the janesusa.com/trainings website. Many of them are approved for CEU credits with the Irrigation Association, and it's November 3rd. We're getting down to the end of the year, so you might be needing some educational credits. That's a great place to find them. We're also anywhere you listen to your favorite podcasts, you can find us there as well. We will be back on Friday with Andy Bellingary, and Andy's going to be talking about how to put your landscape to bed for the winter, what you should be doing so that you ensure a good spring startup when spring comes back. So anyway, thanks again, Michael. Great job. Appreciate you putting your contact information up. I sure hope all of you will use that as you improve your skills with valve troubleshooting. Thanks again, and we'll see you all on Friday. Thank you.